I wonder if this has been recording audio all that time, because I've only just plugged it in properly.
Okay, so sadly up until that point we weren't actually recording audio with the camera. Now I've already made quite a few clips and I didn't really want to see them go to waste, so I'm going to try and overlay here what's been going on so that you can still see them. So as you can see at the moment, we've got James, Ruin, and there's me doing some drilling. Chris was actually videoing at this point. We had everyone down for the weekend, so we all thought we'd put some time in and make up some ramps to go in front and behind the dyno. So we've got James outside cleaning off some rust. Ruin's got the Lincoln out. He doesn't have much chance to do some welding, so he's trying her out. And I'm doing some holes in the pit to mount them. So you can see after the job, we didn't actually get much videoing done with everyone there because we were kind of messing around and we were quite busy in general, so the camera only came out now and again. But as you can see now, everything's together. We've given them a quick paint job. The two ramps you can see at the rear, obviously so you can drop back down on the pit, they are hopefully going to be a permanent thing. The ones you can see at the front are largely probably only going to be temporary. But we've made them up for now because I have got hopefully another set of X-trailer ramps to go there, but they're not here at the moment, and obviously we need something to get up and onto the pit stroke the dyno. So we've made them up. They're actually made up of the old cover plates that used to go around the old Clayton, which you might recognise the steel. So nice heavy steel, but it looks a bit of a bodge on the front. They're not really wide enough, but they'll do the job for at the moment. So you can see everything's sort of in the hole now, all painted up, looking fairly okay. The retarder's just loosely in the frame. All the bearings are greased up and things are largely ready to go. Now I can't really remember what I was talking about at this point, but I was giving it a spin, I think probably to show the amount of inertia in this unit. Big heavy rollers, and there's a lot of inertia in the retarder itself, which is a good thing. I think I was now talking about possibly the alignment of the retarder, but I can't really remember. So I was probably just going on about how we've been trying to make sure we've got the retarder in line with the roller by using a dial gauge and sort of looking for run out on the rubber joint in between the two. And now I think I was talking about the ramps we've made so you can move them left and right. Again, this is because the ramps we've temporarily made aren't really wide enough to accommodate all different car scenarios, so we've had to make it so they move. But hopefully the new ramps will eradicate that problem. So everything's in there. It's really time to start wiring stuff up and adding all the sort of essentials to make the dyno work. So yes, right, so now that the sort of dyno rollers and retarder etc are in situ and fixed, it's time to start focusing attention to kind of getting things working. So you can see here I was talking about the sensor in my hand, which is a Hall type sensor. So this is going to be used for basically picking up the speed of the front roller in the dyno. So the computer will obviously read that so it knows how fast the car is travelling on top of the rollers. So for cars that we can't connect directly via OBD or with an RPM sort of pickup, this is then used to calculate basically engine RPM while you're on the dyno. So you'll run it up to a fixed, a known RPM in whatever gear you're going to perform a sweep in. You'll then tell the computer how many RPMs the engine's doing using a tacho in the car or a digital laser one. And it will then synchronize the roller speed versus the engine speed, which then enables you to do that. So it's just a normal 5-volt supply sensor, so we'll need to make up a mounting bracket to sit that to the right hand side of the retarder there. Okay, moving over to the bench now, you can see we've got a new load cell and the two rose joints sat on the bench there. So this is basically the same as the last dyno. This will be mounted on the side of the retarder to measure torque at the roller. Obviously the two rose joints, just normal M12 generic ones, will be used to mount it to A, the retarder frame, and B, the chassis of the dyno. So this will then basically stop the retarder from rotating, so when there's load on the retarder, that load is transmitted through this load cell to the chassis, which is then able to read torque. And because you can read torque at the roller, you put it through the gear ratio, which is known, to work out torque at the engine or the crankshaft. Right, so now that we've started getting things connected up, we were basically at a point where we kind of needed a car sat on the dyno to perform some basic tests to sort of check that things were working. So run the speed sensor up to speed, make sure that the load cell is picking up, etc. Make sure and obviously check for any other sort of obvious problems with the setup. So attention sort of, well, we got a car on the dyno and obviously our attention was then sort of spanned over to strapping down. If you remember on the Clayton, we used to have two straps at the front and obviously the two on the rear. Now obviously the two on the rear aren't going to be affected, they're still in use as they were before. But the two which were behind the front wheels, where I was pointing my finger, originally were attached to the actual frame of the dyno. Now we can't do that anymore, basically because the frame of the dyno is actually not technically secure to the dyno itself. It's only really screwed to the concrete walls, so I wouldn't want to put the huge sort of strain of the straps etc onto that in the event of a problem with the car moving around. That could obviously cause a problem. So we decided to make some new anchor points that we would sink into the floor in concrete. So you can see what I've made up here in front of you. So it's basically 4 pieces of 2-inch box, and I've welded some flat on the top. So the idea being that we'll sink 2 of these behind the front wheels and 2 in front. You'll be able to sink in, hook in a normal strap hook into the top of them, so they can't fall out, and obviously they'll be sunk the full depth that you can see into the ground in solid concrete, so they won't be moving anywhere. And we'll have the 2 additional ones in front of the front wheels as well, so overall should be much better than before. Okay, so here you can see Chris is on his way down through the concrete with a masonry core drill. So we decided to drill the holes right down through the concrete with one of these to save kangaroing and making a big mess. Idea being it will look a bit tidy when it's finished. So you can see the 4 holes that we've done. Notice also the really good depth of concrete we already had in the workshop. So that alone, with concrete between that and the thing, will be extremely strong. Not to mention the extra sort of 12 inches plus down below into the ground that they're going to be sunk in. So just having another look there at the what we're going to drop in to allow the hooks to hook in. Quite a dusty job, but doesn't take too long overall, and should hopefully provide a much better way of strapping the car down than before. Also avoids the straps being too close to the car, which we found was a bit of an issue before. And there we have them after concreted in. So we put a bit of red paint on them just so to try and avoid tripping over them. Although I think we probably have a couple of times already, just not sort of being used to them being there. We were going to flush mount them originally, but decided in the end that was going to cause the straps to chafe on the side of the frame, which wouldn't be a great idea in the long term. So brought them up through. So hopefully that should be okay. So they're in now, they're setting off, so you can see the position where we've got the 2 basically in line with where they used to be, and also the 2 additional ones that we can use to strap into towing eyes etc for ease in the front, and the same on the other side, as you can see. Right, so as with the last dyno, or any dyno for that matter, you can see here I am calibrating the unit using a weight. So I've made up an arm similar to the last dyno. In this case we're using a 50 kilo weight, hung 35 centimeters from the centre of the shaft. So with those 2 pieces of information, the weight and the distance, you are able to calculate the torque at the roller. So then you can then zero the load cell with no weight, and the scale factor, which is when the weight is on. So thanks for watching. Hopefully the next audio will be back with the video as it was supposed to be in the first place.